So for this one, this is an equation. So with absolute value. So just like we saw already, right? Remember what you want to do is you're going to have two equations that you're going to have to solve. You're going to have to solve when what's inside here equals 8. And the other one is when what's inside here, the negative 3x plus 9, when that equals negative 8. So we're solving this equation. So this is the first one we're solving, that is. So we have negative 3x plus 9 is 8. Okay? So just like before, we must get x all alone. So solving both sides for x, we subtract 9 from both sides, right? Here's cancels, we get negative 1 on the right. So we have negative 3x is negative 1. From here to here, right? We can divide by negative 3, and we get x equals 1 over 3. So that's what we have here. Now that's one equation. So we have one solution at least. We have 1/3. For the other one, we have to solve this one with negative 8. And these are it's basically the same steps. Of course, the answer is going to be different because we have negative 8 here. So we have negative 3x plus 9 is negative 8. Subtract 9 from each side, as you can see. And so we get negative 3x is negative 17. Then, of course, we divide it by negative 3, as you can see. And of course, the negative 3's cancel, so we get x is 17 over 3. Good. All right. So our two solutions were 1/3 and 17 over 3. 1 over 3 and 17 over 3. Okay, that was fun. Okay. Here's another one I want everyone to try. I'll just stop the recording. Okay. I figured also it'd be good to try out this one. Again, if you can't see it, just, they have the zoom features you have with Blackboard. All right, so for this one, we have an absolute value, right? We have absolute value and an inequality to solve. So we're going to get a compound inequality, right? As we saw before. So from here, we have this compound inequality to solve, right? From here, we have 7x plus 5 in absolute value is less than or equal to 6. We have 7x plus 5 less than or equal to 6, greater than or equal to negative 6. So from here, we want to get x all alone in the middle. So what do we do next? Well, what I did was I subtracted 5 from both sides, right? That doesn't change the inequality signs. So we get 7x, as you can see, between negative 11 and 1. Then we want to get x, so we divide both sides by 7, as you can see. Right? We divide everything by 7. Now 7 is positive. So because of that, we don't change the inequalities. That is, we don't turn them around. So in the middle here, I wrote this line twice. I'm not sure why I did that, but we end up with x in the middle. We have negative 11 over 7, less than or equal to x less than or equal to 1 over 7. And so I did graph that set. Here's the solution set. We have a closed interval. And I did graph it as well, as you can see. Right? Namely, we have the two closed circles over the endpoints. We're including them because we don't have strict inequality. So I thought it would be good to do that. All right. So that's one example. Okay, good. All right, let's do another one then. So again, here's another one. This is actually, yeah, so let me let you try this one on your own. Just pause. Okay, so we have this going. Wait, okay, good. You can hear me. All right, so here we go. So for this one, right, again, we have, oh, sorry, we have an inequality, and, oh, I was right, it's supposed to be strict. All right, sorry, it was supposed to be strict. I don't know why I thought it would be, all right, well, whatever. Anyway, let me just fix that, actually. So, sorry, it was supposed to be strict. Sorry about that. All right, anyway, so for this one, we do get a compound inequality, right? Basically, we have from here, we're going to get this. That's what we end up with. So we have to solve this here. And just like before, you always want to get x all alone in the middle. You want x to be all alone in the middle. So because of that, we have negative 4x plus 12, right? So the first thing I did, at least, was I subtracted 12 from each side, from all three sides. Doing so, we're going to get negative 4x in the middle. We get negative 22 on the left. And we get negative 2 on the right side. What's next? We divide by negative 4. Okay, and again, you're dividing by a negative, right? If you multiply or divide by a negative, you have to flip the inequality symbol. You know, invert it, that is, or turn it around. That's what I'm doing here, see? So we get x is in the middle, less than 22 over 4, greater than a half. 22 over 4 you could write as 11 over 2, but I would just leave it like that. So we have this open interval. As you can see. Not only that, we have open circles over the endpoints, right? This is strict inequality in both of them. We don't include the endpoints, as you can see. Okay, that's good. All right, so that's the end of that. Are there any, oh, sorry. Are there any, what do you call it, questions on that? Or, because I figured we start, not finish, of course, but start chapter 2. So I think everyone's okay. All right. Let's start chapter 2 then. Wait, let me. Okay, so I'm going to start chapter 2. I'm not going to cover everything, of course, in chapter 2, especially not in one sitting. So, you know, you only have to know what I cover. What I'm starting with now is section 2.1, and that goes into the Cartesian plane. Now, so basically in section 2.1, the idea, at least one of the goals, is to see what the XY plane, that is the XY coordinate plane, also called the Cartesian plane, see what that is. And I'm guessing you've seen that before. If you haven't, that's okay, although I can't imagine you haven't, only because it's used so frequently. You know, in many of the sciences, and not every math class, but in many of them, you know, you have to graph something in two variables, x and y. What you're graphing in is the Cartesian plane. We also have a way to get the distance between two different points. I guess actually any 2 points in the Cartesian plane. There is a formula for that, which I will present. What's nice about the formula is it's actually based on Pythagorean's theorem. You know, it's a theorem for right triangles. We also have a midpoint formula. Basically, the idea there is if you take two different points in the plane, you can connect the 2 points by a straight line segment. Now, I'm not sure if that's an axiom, that is, if it's something you can assume or if it's something that can be proven, but for us, let's just take it as something that's true. And the midpoint is the point on that line segment halfway between, distance-wise, between the endpoints. Okay, so let's see, we have a minute left. I really don't think it's good to get beyond this because this is what I got up to in the other class. So I guess we could stop here, actually. It's probably a good place to stop because this is where I got up to in the other class. So, okay, let me just